visualizations and front-end stuff, things in JavaScript. And I had no experience in machine learning or Python.
I studied electronic engineering degree 15 years ago, but haven't really used it at all since. So this course has been a really steep learning curve for me. Yeah, I don't do anything like that in my day-to-day life, so it's been difficult and quite fun.
I'm Lisa. I've been in construction for 15 years. I don't have a background in machine learning. Until we did this, I hadn't written a line of Python in my life. And this is hopefully show you a bit about what we three completely unexperienced people achieved. So we were looking into.
Was I going to do this?
Yeah.
Okay. So we wanted to know about the things that we know about film before it's made. And so rather than looking at features that kind of happen after the fact, like which might be Facebook likes, which would be nice because they're nice and numerical. But so we wanted to look at. So we wanted to be able to predict the gross earnings of a film based on the budget, the director's average gross earnings of their film, the genre, the content rating, the duration of the film. What was nice about these is that they're all very different types of features, so we got to use lots of different sorts of analysis. With the director's earnings, that's something we had to work out from the data, so it wasn't just there in the data, we had to do some manipulation to get that ourselves. Well, one of the things that we wanted to look at but couldn't was I have heard that the number of syllables in a person's name affects how successful they are. So we wanted to look at whether the lead actor's name would affect the gross earnings of the film. But however, we discovered there wasn't actually any kind of library for syllables in names. So we had to scrap that. But that would have been nice to. We could have found one. It would have been really nice to do.
Yeah, so what we're trying to do here is, like, if I'm pitching my movie to this movie company or a bunch of investors, that they can just run these algorithms and then tell from it whether or not it's going to be a success or not success. So whether or not it's profitable or not, and the possible of return on investment. So there are a few of these things, like the genre and the content rating, that will tell you something on the content of the movie, which I thought was quite interesting, but we'll see how we do with that. And the other ones is how much money you actually throw at the movie, on the marketing and the making of the movie, or how successful your director is from previous history. And the duration, I think we just threw in, let's see if that made any difference at all. So the pre-processing part of it, like you have in other groups, is quite a big and important part of it, involving removing everything that's all the values that are null, and if you find any duplicates, remove those. And we also discovered that the currency of the gross and budget was, the budget was in the currency where the movie was made. So rather than going down the route of actually finding out the exchange rate at the time for every single country that was present in our database, we just ditched the whole and just went the American, the USA movies for simplicity and time. And then we had to correct for inflation, which we did by finding the US data, the US I think you find the US government data for inflation, but luckily went back all the way back to the beginning of the first movies in our database. We could then correct for inflation. And then we went through, calculated the director's track records by finding all the movies that this director had been in before, and international movies, so we didn't have the problem of trying to figure out what the different content ratings actually meant, but we were stuck with the American ones, but it turns out that the American ones also have changed over time. So what was rating in the, well, this goes back to 68, but there was even movies before then that had different ratings, so they had to be grouped into what is today GPPG13R and NC17 ratings that are used today. So that was a bit of data processing that had to be done before we could actually use that as one of our features. So start with data. This data is the same data as all other groups use, I think. It's the one from the Kaggle website, which is a subset of all the movies in iMDB. I think you can probably tell me how many movies you have in your database, but it's millions, basically. Yeah.
How does it hang then?
It's 5,044. So this is just a very small subset. And after we got rid of all the nulls and all the non-American movies and doing all these things on it, we were left with 2,941 and 28 features. And that we were interested in. We got rid of the Facebook likes and actors and all these things that we weren't interested in. So the 4 content rating, director average, earnings, the gross, and the budget, plus the 4, and the 25 different genres. That we did the same thing, that we split it out over, it was 25 different kinds of genres, we split it out over 25 pages. So we looked at this data and tried to work out the significance and how they correlate against each other. And for the features, I don't think that you can say anything very interesting. I mean, you can make some correlations. The animations and family movies correlate, which is expected. And this one really surprised me. The family and the content rating did not correlate, but then we realized they did correlate overtly. So that threw me a bit. But, there is some correlation, but you know, action and thriller is more correlated than action and thriller and animation. All things that you would expect, really. For the other 4 features, though, we could tell that the average duration and budget seem to be somehow correlated, and the average gross and budget are correlated, which is would expect as well, I think, but not the content rating and the budget. That's that relationship, it seems. Okay. Yeah. So profit. So we just divided our data into profit-making movies and non-profit-making movies. So the profit flag. And that's how we judged our result. And we came to the same conclusion as you did, that we need to understand how well our models are performing by understanding. If we just had this binary measurement profit, I was first running my different models, and I thought I got this number quite a lot, 60.3, and I thought that's funny. It keeps on coming up in all the different kind of classifications that I'm trying out. And I realized that 60.3 of all the movies that we had in our database, data set, were actually profit-making. So that if our models were predicting that they were all profit-making, I got 60%, 60.3% accuracy, which I thought was kind of good, but turned out that's not good.
Okay, so I'm going to talk through a little bit a couple of the models. We use 2 different types of classifiers. So to start off with, we've got this binary classification problem that we're starting with. Is it going to return you more money than you spend, or is it going to cost more money than you're going to make on it? We used first up the k-nearest neighbour classifier for that. We got about 60% accuracy, so we know from looking at the data that's not particularly helpful. But what you can see here is that it's reasonably, so this chart is what it predicted it would make money or it would lose money, and whether it actually made money or lost money. So this is true positive, and that's true negative, and these are the false responses. So you can see it's fairly good at predicting films that will make money, but it's not picking up the ones that won't make any money. And you can see that here also in, this is just an average accuracy, but these are two other types of measures for accuracy, how precise the model is. So if out of all the results I predict to be true, how many of them actually were true? And recall is to say, out of all of the results that actually were true, how many did I pick up? So you can see we're scoring quite well on the profit-making movies, but not so well on the loss-making movies. So then we went on to a different classifier, a random forest classifier, which is a bunch of decision tree models. This is useful because you can also find out the significance of the different features that you're using. We established quite early on that the genres were really not contributing at all to the results, so we kind of threw all of that away and concentrated on these four. So our overall accuracy has gone up a bit, and you can see we're picking up the flops more strongly, and you can see again down here that these the prediction of the loss-making movies has improved. So 74% compared to 60, which is what we would be getting if we just guessed positive all the time. So then we had to move on to from a binary classifier to a multi-class classifier.
Yeah, so thinking it might be interesting for a prospective investor to know just not if it's a possible profit-making movie or not that they're investing in, or if the return on the investment, if how likely is this can actually give you really lots of money back on your investment. So looking at that, trying to first looking at the profit that these movies have made, and then looking at the return on investment versus the profit versus the spending on it. So working at the return on investment, and then so that's different number for each of them. So put it in buckets so we have something to classify against. And they seem to be a bit of an exponential curve. Most movies make some money, but not huge amounts of money. But there are some that make loads of money, as you can see here, and they're very unevenly distributed. So that's skewed our data. And what we're seeing here is two movies, that one and that one, are completely out of the range of all the other ones. So I was quite interested to see what are these movies and what they're doing. Is this some kind of error in my data? And it turns out that both of them are horror movies, kind of webcam, shaky horror movies. The highest kind of return on investment movie of all times is called Paranormal Activity, 2007 horror movie made with a shaky cam. And I never heard of it, but it's apparently quite well known that it did really, really well.
But this is because they had tiny budgets,
yeah.
So that's why their return.
So not that they actually made so much, didn't make as much money as Titanic or Avatar, but they had such a tiny budget. And the second one, actually I have heard of, because it's Blair Witch Project. So I thought, but that is so out of the norm of anything, so I'm just going to ditch those because I think it's going to skew my results. So I got rid of them, and this is what I ended up with, something that was a little bit better distributed over my, these little lines there are the movies and where they are in my distribution plot. Most of them by far in this area. Yeah.
Okay. So now that's how we produce the buckets, which make the multi-class answers. So these, again, it's the confusion matrix, but these are our sort of bins for our profitability. Naught being makes less money than you spent on it, and everything else being made a multiple of its original budget. Now this becomes a lot more complicated question, and our accuracy overall has dropped down quite a lot. So again, we've gone back to the K nearest neighbour. The main effect here is that this model is predicting flops when actually some of these things it's predicting as a flop did actually make money. So it's pretty good at the true negatives, but the false negatives are kind of skewing it out again. So you can see here that that's impacting the recall on the profit making and the precision on the loss making. When you average all of that, you get 40%. So again, compared to our target, not so great. So we ran it again with random forest, and this performs a lot better, comes up to nearer 50% accuracy, and you can see that it's got better at not predicting false negatives, and you've got a sort of more even distribution of the results. And the feature significance, the directors become a bit less significant in predicting how many times you're going to make your money back, and the content rating and the duration have become a little bit more significant. But we got quite a nice balance between all of these different accuracy measures.
So, what we would do next? Firstly, probably the answer to most data science questions next is we would get more data. These 3,000 films is obviously a tiny proportion of the ones out there. We'd also do some parameter sweeping.
Yeah, so the different classification models, we just use them more or less as the docs. We have tried a few different, we're changing the parameters a bit, but not very much. And I think that if we had more time to kind of go more into understanding what is, how we can shape these classifiers to get the best results.
Yeah, we'd split out the content rating feature, so at the moment we're using it as a continuous scale, but actually what we'd want to do is have it as an on-off. We look in more detail at the scaling, because we needed normalisation and we don't know at all whether standardisation would be better for what we did. And we'd also look at the one-away results. So that's a better definition of accuracy. So how close.
In the multi-classification problem.
Okay, and then finally we thought, well, let's ask, is our accuracy any good? So for the binary model, we knew we had to get at least 60% for it to be better than just saying every film's going to make some money, and we achieved 74%, so that's better. Then on the multi-class model, this week we thought, well, let's see if anybody else has tried to solve this problem, and we found a couple of references. Out of all of the other people on Kaggle doing this, the best average bin accuracy is 33%. We achieved nearly 50%. And there's a paper in the Journal of Expert Systems and Applications that used a neural network to do this, and their average bin accuracy was 37%. So we're quite encouraged by that, but we probably want to investigate a little bit more. Why is the question? So yeah, thank you.
Is there any questions for this group? Our last group? Questions?
You know, you've got those two extremes, and you kind of deem them out. Those. Did you ever put them back in and rerun the model to see what that did to it?
I mean, that's one of the things I would like to do, is to really look at the bins, and how I think there's a bit more work to be done on that one, because it's quite crude measurements and easily put together. I think putting them, I didn't try now, but it's one of the things.
So how many of those films, I mean, I understand why they were successful because they're so low budgets. How many films had similarly low budgets?
We didn't.
Well,
There's only two data set that was really sticking out as being.
I know in terms of just the budget though, there might have been others that weren't so successful,
Yeah.
but were still there. Is there many of those that are low budget films? But I
Yes.
understand only those two
I think
were really
there's-
successful.
There seems to be quite a lot of documentaries and things
Of a
low-
similar budget.
very low budget ones. Yeah. But then again, the budget data you can ask where does that data come from? Because I did look at that particular movie, Paranormal Activity, had a budget on iMDb that was $15,000, and it made a lot of money. It made 100 million or something. But then looking at another source, which called the numbers, that rates budget data with movies, it came up as 450,000. So where
It
does
could be an error in the data.
how this data came into the database, how submitted by the people that made the movie, or is it when the movie was just after it was released, if it was happened like years after, merchandise, I don't know.
Yes,
Really
yes,
strong
they could-
construction costs and the other.
Yes, exactly.
Yeah.
Yeah. But that question of how you make the bins is really critical, and you could go, I mean, there's a never-ending degree of complexity you could put into that, into how you scale the bins up and down to, do you want the same number of films in each one in your test, in your training data, or do you want them to be equally banded, or, you know, all sorts of probabilistic ways of doing it, which, given more time, could be investigated.
I love that you got a better result than those people who spend like months on these things. That's really good. It shows how fickle the actual relationship is. Really.
So did you reject those as outliers because you thought there was an inaccuracy in the
I
data?
was unsure,
or
yeah.
It was suspicious because that would make it a
I
legitimate
was
outlier.
suspicious. I was suspicious
Right,
of that
so-
particular one. I thought maybe they've been very optimistic when they say they spent 15,000 on a multi-millions grossing movie. I think that they probably spent an interest.
There was also a question of to get to some results in some time and understand what we'd done to get there and what we would do next. And it was a kind of, well, we could spend a lot more time validating these specific bits, or we could chuck them away, carry on with the bulk of the other 4,000 and something films, get the result, and then put it on the list of come back to do later.
Any last question?
Yeah, I came in halfway through the talk, so I could have missed something at the start. But as far as like features go, do you guys consider like genre or like actors or actresses or whoever is in like
We
the
did do genres and they had no significant effect on that. So we threw it away.
Sadly, we really wanted the genre,
We wanted something that actually
something
told
about
us
the character of
it.
the film to influence how profitable it was, but it didn't.
It seems like the main star in the movie should have some fruit out. Like Adam Sandler's an idiot, but he keeps making movies, so it's got to. If he's in it, it's got to make money.
Yeah. So out of the features that we selected, we tried to pick one of sort of each kind of type. So one that was straight out and out financial, one that was to do with experience of the cast and crew, one that was to do with character of the movie, and so the one around experience, we picked the director's back catalogue. You could have picked the lead actor's back catalogue or lead, Facebook likes as one of the other groups did, but we picked.
Yeah, we
one.
did think about that, but we rejected it anyway. We did look at exploring the actor's name to do some text analysis, but actually it ended up being too tricky.
Okay, great.
I just got,
Oh.
can I just ask something? To do with the, because it's the gross you're saying that it's against, is that the money that is just raised straight away, or like the box office?
Yeah. So it's only in the database, the data set only contains US box office earnings. It doesn't contain merchandising or ongoing box office from other countries, etc. So it's massively underestimating the return in most cases, I would say, unless it's a film that never exports outside of the US. But that's where some of the currency issues come up, because there were some films that had huge budgets, but it was in Korean won, but then the box office is in dollars, and it was made in 1962, and you think, well, you could work all that out, or we could just only do the US films.
Okay, great. Thank you so much.